Okay, so they give us a graph of a function f of x. So we can call this f of x. And they want us to graph the inverse. So one way you could do it, you could look at the points and the characteristics of the graph and then switch the x and y. So if you look at this graph they have drawn, it looks like there's an asymptote at the y-axis, right? So in the inverse, it's going to have an asymptote at the x-axis, right? Switching the x's and y's. Asymptote. So that's helpful to us. Then we want to look at some points from the function. So f of x, well, it looks like I can see a point here at 0, 1. I'm sorry, 1, 0. Say it wrong, goodness sakes. 1, 0. And it looks like I have a point here at 4, 2. And I pretty much know what that curve looks like. You might say, well, why don't you pick 2, 1? Okay, let's pick that one. 2, 1. Now, what's going to happen for the inverse? Well, it's the switch, right? So the x's become y's and the y's become x's. So now we have the point 0, 1, 2, 4, and 1, 2. I think this is the easiest way to do it, but you might have other ways. So I'm graphing these points now. 2, 4, and 1, 1, 2. There it is. Now, I have to make sure I keep the integrity of the graph. You could even make a fourth point. It looks like there's a point right there that's about 1/2, negative 1. Now, when you switch that for the inverse, it's going to be negative 1, 1/2. So we can graph that. Might make it a little bit easier. So we know it's going to run asymptotic to the x-axis. So we have sketched a graph then of the inverse for that function they gave us. Now, is it symmetric about that diagonal line? So I'm drawing in that green line. That green line is the y equals x line. And is it symmetric? Could I fold my paper along the green line and have the orange points line up with the blue points? And yeah, it is. Okay, so those are pretty fun.